Welcome back to the System Design series. In this one, we have, or we should have, some interesting content, and I hopefully we can talk about it out loud and work through the problem verbally. And before we get into it, when you are in a technical interview, it's very, very important that you think out loud and you process out loud and you ask your questions that you're thinking out loud. Whether or not you think that they're correct or accurate, it's important that you show what your process of thinking is. And that's really a lot of what the technical interviews come down to. It's not about perfect code, some syntax, all that stuff. It's about your process. And the only way to articulate your process is to say it, write it down, and discuss it with the interviewer. So that's what we're going to try to do here, because that in and of itself is a skill. And it's a skill that I was not good at starting out, and I just don't think I'm very good at it now, but we're trying to get better. So this is going to be building on the last video where we split our database into 3 different nodes. So we have a master and 2 child nodes that are kept up to date. But we are still having issues. And the issue that we are facing now is that we are having failed write operations. So we're experiencing failures due to timeouts, exceptions, etc. But all we really need to focus on is that we're having failures from our .NET API when we're trying to write to our master node. So immediately when I think about this problem, I think about 3 things. I think about 3 questions. So the questions that I have are: does the data need to be written immediately to the database? Do we need to be notified when the data updates, meaning when we have successfully updated or written to the database? And do we need a form of retry policy, meaning if we try to write to the database once and it fails, do we need to try again, or do we just log the error and then continue and get out of there? Those are 3 questions that I would ask personally if I was faced with this problem in an interview, because I think that you can derive a lot from these questions. I think that you can expand upon these in a number of ways. But let's break this down question by question. So the first question: does the data need to be written immediately to the database? This is really getting at, do we need to be performing all the write operations specifically from the .NET API? Or can we offload that to another API to handle the processing? Because a lot of times what happens if you try to always spam your database with a lot of write operations, it'll start out good. But depending on the table structure of your database, if your scheme is really complex and you have a lot of joins, you have a lot of foreign keys, you'll begin to notice a tick up of latency over time. And sometimes that can lead to timeout exceptions when you didn't expect. And so part of this question is asking is, do we need to always send the data immediately to the database? Or can we rather offload that to be processed perhaps at a little bit later time? And a later time can be 5 seconds later, right? It doesn't need to be like, I'm not talking about, minutes or hours, right? And so this question I would take as, I would assume that the answer to this is no, right? Some of the data we can determine that, it does not need to be written immediately to the database upon receiving that information, right? And this can be an example of if you've ever visited a website, let's say YouTube, and you updated a description, and then you went to another tab and you refreshed and you didn't see that data immediately. This is an example of an instance where we probably are encountering that data being processed later, either through the database or it's being processed somehow but not immediately. So we're going to assume that in our system we have some data that we can process at a later date. So given this issue, I am going to make the assumption with that, and I'm going to introduce a new .NET API, but this one we're going to call a .NET background service. Hold on here. We're going to call this background. Here we go. All right, so we have a .NET background service. Um, actually, we can call it that. It's like you can call it a hosted service in .NET technically, but we're going to have some running process in the background that's going to be sitting here. Now you're thinking, okay, well, what is that? How does that help? I'm going to show you. So let me move these questions off to the side so we have a little space. I need to establish now a connection between my .NET API to the .NET background service because we need some way to say, hey, I see this data, but I don't want to process it immediately. I want to process it at a little bit later date and then send it to and then write it to the master database instance. So in order to do this, I'm going to introduce a queue. And we'll give, what shape do we want the queue to be? Do we want the queue to be a circle, an oval, a triangle? I'll make it what do we want? That one looks too similar. We'll make it a diamond, I guess. I don't know. I don't know. I don't want to make it the same as my database, but I'll just make it this diamond and I'll give it a color. We'll give it a purple. So all that needs to be said about this is that it's a queue, and you can leave it at that, because the interviewer should recognize what a queue is and does, and you shouldn't hopefully have to expand into that. So I'm gonna draw some lines here. So what this is going to be representing is that the .NET API is going to now be sending some of the data, again depending on what the data is. We're going to be publishing a message to that queue. And if you've ever worked with queues, that's a near instant operation because there's no response back from the queue depending on the protocol. So we're going to be publishing that data to the queue, and then it's going to be sitting in the queue. And now we have to register a consumer to that queue, and that consumer is going to be the .NET background service. So now we've established a connection to our .NET API to our background service. And you may be asking, okay, well, why don't we just send our .NET API and send the data directly from that to our background service? You don't want to do this because there is probably going to be some latency between the background service connecting to the database. And so we don't want to create a bottleneck there that will slow our .NET API down. So you always want to introduce a queue whenever you're doing something like this, because the queue will allow for asynchronous data flow, and there won't be any latency in our .NET API. So I'm going to color these. We'll color them green, I guess, to show that they're new. So let me just color these. We'll color them green. Okay, so we have our data flowing here. We'll just say we publish the data, we consume the data, and that's just terminology for working with queues. You have a publisher and a consumer, and we write the data to the database. So now we've created this flow where now we have offloaded some of our write operations to this new path to be processed by our .NET background service that will write the data. So now we've offloaded some of our write operations away from our .NET API. Now we've introduced it into this new flow. And so that's a really, really good way to offload some of our write operations to be then processed at a later time. And you can set this up. You can configure your consumer however you want. If you want to just have, you can define the prefetch count. You can define if you want some kind of retry policy. You can define how often you are pulling from that queue. There's a number of different ways depending on the message broker in the queue that you have decided to use. But it really doesn't matter for this case, but this is the flow that we're going to introduce. So now that I think answers part of our first question. We can leave it at that. So I'm going to move on to the second question, and that is, do we need to be notified? What in the world? Wait, did you see the balloons? What was that for? Is it from... What is happening? I think that's from my iPhone. Is it the peace sign? Is that what's doing it? Are you kidding me? Look at that thing. That's okay. Well, hopefully that doesn't happen in the interview, but if it does, maybe it's a good way to break the tension. You always got to make them laugh. So the second question is, do we need to be notified when the data updates? And the answer to this, it may be yes, it may be no, but we'll say for this example is yes, we should be notified when the data updates. And so you may be thinking that, okay, well, now we have a scenario where our database is, we'll say it's a MySQL database. So we're not going to have any like direct change log or data capture implementation. And so I would really like to move that off of the database to create some form of queue-based way to see if it updated. And how I would choose to do this to make it really irrespective of whatever database you're working in, because I don't really like to include a lot of logic directly built into the database. And since we have already introduced a queue here, what we can do is, what we can do is actually introduce another queue, and I'm trying to think of where I can put this to see if it all fits. So we can have another queue here. And what we can do is introduce yet another path, and we'll give this a different color. We'll give this pink, and we'll send data to this queue. So we've introduced another queue, and basically what this queue is going to do is we are going to say that this is going to consist of our updated data. And so what this is actually, I need to move it down here because I need my API to interact with that as well. Okay, so what we're going to assume that this is we're going to say, okay, when we have a successful write to the database, to our master node, we're going to actually basically publish a message. We're going to publish a message to this queue that will contain whatever data we just posted to the database. So depending on how we structure our SQL, if we decide to do a select query right after our update or write, whatever it is, we can publish that. I want to have this background service publish that to another queue. The reason I want to do this is because that if it is an update query, then we'll probably have some data that we didn't have contained in the data that we were working with initially. So again, depending on the database, depending on our SQL, we're going to assume that we have that updated data that we can then publish to this queue. And so now we need to be notified when the data updates. So what I want to do is add a listener. Well, actually, before we add a listener, I'm going to have the .NET API do the exact same thing. So I want to have the publish updated data happen from the .NET API as well. Because, remember, we have some write operations still occurring from this .NET API here. And so if we don't publish the updated data from this .NET API as well, we'd only have partial updated data going to this queue here. So that's important. So basically now, all we need to do is we need to be notified when the data updates. So what I can do is either two things. I can add a listener on my .NET API, or I can introduce another background service to listen to that queue to provide updates. And I'm going to actually introduce a new background service that I'm going to say is going to be consuming off of this queue. So I'm going to copy this here and consume updated data. Now we have this freedom to say, okay, this .NET background service is now consuming all that updated data right off the queue. There's going to be no latency, and we're going to have everything built in, all the features that queues bring with it and message brokers built in that we can configure however we want. So it's going to be really, really nice. And if we need to be notified when the data updates, now this .NET background service can do that. So whether that's use SignalR to update the front end, whether that's publish a message for another part of our system to react to, we have that capability now introduced here, and there's going to be no latency. So I think this is really, really nice. So I think that answers the second question. Do we need to be notified when the data updates? The last question is, do we need a form of retry policy? And this is important because if we do need a form of retry policy, we need to add code into our system to accommodate that. So what we can do here, we'll start with the .NET background service writing to the database master node. So we have a write data operation happening. And basically what we can do is you can set up basically not a trigger, but it's a Boolean value that you can set to basically add a retry policy to this master connection of the database in the code. If it's a MySQL database, you can do that. There's a number of different ways to do that. But basically, we can do it on the database side like that. We can set up either a try catch. We can set up a manual retry policy. We can use a package to do that. But if we want to focus on this side of things from the .NET background service and the queue, we can use a message broker and use built-in features to do that. So one example of this would be we're going to expand on our assumption. We're going to use mass transit. And again, if you've watched videos on my channel before, I've showed you how to do this step by step and exactly what you need to do to set up a very sophisticated retry policy with mass transit in one line of code. So it's very, very nice. So mass transit is a message broker library available to us in .NET. So we're going to use mass transit and we're going to add a retry policy. So basically, if this write data fails, if this write operation fails, we are basically going to not send an acknowledgement back to the queue. And if it's RabbitMQ, which is my assumption that it is, that uses the AMQ protocol. And part of that protocol relies on acknowledgements. So basically, this retry policy will exploit that feature and say, okay, if we don't send a proper acknowledgement back, we are actually going to push that data back to the queue to then be consumed again. And then we consume it again and try again. So that's our retry policy. So we can set that to however many times we need to do that. Doesn't matter, we can specify. So that's another way we can add a form of retry, is through existing message broker libraries that have this functionality built in, but we can just talk through how we would go about doing that. And the same thing goes for this write operation here. We can either specify that on the .NET side of things, or I'm not going to diagram this, or we can introduce the same functionality as we did through the .NET background service. We can introduce another layer to have happen here with a queue and another service to exploit that same functionality. So it's really, really nice. Queues add a ton of functionality to your system, and the power that you get with that and these message brokers is just incredible. And you can create seriously sophisticated systems that are very, very resilient and that just work very well. And you can send millions and millions of messages per minute and have no issues whatsoever. Super powerful stuff. And so I think that answers our 3 questions. We now have a little bit of a web of stuff happening, but it's once you get into the code, and again, we've gone into the code on this channel very in depth. Once you get into it, it's not too crazy. And once you have it set up, you won't have to touch it again. It just works really, really well. So in the interview, this is some things that you could ask and one potential structure of how you can do this. So hopefully that makes sense. And I know when you look at it, it looks like some kind of like, it looks like we drew some crazy like rune or something like that, some Icelandic rune. You know, it's funny, actually, Something interesting is that Bluetooth, the name of Bluetooth, Bluetooth was named after Harold Bluetooth, and I believe he was an old, very old an ancient Icelandic explorer. And so the actual Bluetooth logo is a very old Icelandic rune. I don't know. Fun fact of the day that you can end your system design series video with. So, thank you all for watching, and I will see you on the next one.